This is problem number 7 from section 5.4. This is a pretty good problem because it kind of ties together, finding the area under the curve. So let's take a look at what it's asking. It says find the total area of the region between the x-axis and the graph of y equals negative x squared minus 3x. Well, I went ahead and kind of drew just a rough sketch of the graph. So let's take a quick look at the rough sketch of the graph. First of all, it's a parabola, and it's a downward facing parabola. Now, we can find the roots of this really quickly by saying negative x squared minus 3x equals 0. All right, we've done that many times to find the roots. We can factor out negative x. That would leave you with x plus 3 equals 0. So negative x equals 0, or x plus 3 equals 0. X equals 0, or x equal negative 3. So these are the roots for the function. And you can see that I have those roots marked here. All right, so the function goes through these two roots. Now, they tell us to find the total area of the region between the x-axis and the graph. And they give us a region, negative 5 to 2. So that's why you can see I have negative 5 and 2 marked on the graph. So they want us to find, if we mark this off, they want us to find the area between the x-axis and the graph. So they want us to find this area here, and they want us to find this area here, and they want us to find this area here. Now, if you view an example, you're going to see that they talk about doing the absolute value here to find the total area. Well, the area that you get that's above the x-axis, that's going to be a positive area. The areas you get below the x-axis are going to be negative areas. Can you really have negative area? No. So that's why they're going to tell you to take the absolute value of all these and add them together so that you can actually find what's the area of all of these between the x-axis and the graph. So they're going to tell you to take the absolute value of each area, add them up, and that's going to be your total area. Well, let's talk about how we come up with these things. So first of all, I want to do the integration of this function from negative 5 to 2 before I actually show you the solution for the whole problem. So let's go ahead and do this integration then. And I'm just going to kind of keep this down here on the left side so you can see. So let's say I integrate, I'm going to do the integral from negative 5 to 2 of negative x squared minus 3x. That's going to equal negative x cubed over 3 minus 3x squared over 2 from negative 5 to 2. So now I just need to plug those in. So I'm going to say that equals, if I plug in 2, I get negative 2 cubed over 3 minus 3 times 2 squared over 2 minus I have negative 5 cubed in here over 3 minus 3 negative 5 squared all over 2. Now, I think we can do this easier in the calculator, so let's see if we can figure this out in the calculator. We can use the store button, I think, to our advantage here. So let's store the 2 as x. I think this is a good way for you guys to use your integrals as well, or to evaluate these. So let's start with the function. Obviously, we want to start with this integration. We're going to say negative, well, let's make this a fraction first. So we'll say fraction, and we'll say negative x cubed over 3 minus, make another fraction, 3x squared over 2. And you're going to see why this is going to make sense. So we're going to plug in, we already have 2 in for x, we're going to plug that in the calculator. It tells us that we end up with negative 26 over 3. And we need to subtract, right, because of the subtraction sign. We're going to store negative 5 as x, so negative 5, store it as x. Go up and grab that same function, and we get 25 over 6. And then we can actually take and do negative 23 minus 25, and they give you negative 77 over 6. And so you did all that work in the calculator, didn't have to go through do all the fraction work, and they tell you negative 77 over 6. Now what's funny here is they're telling us that the total area of these 3 regions, right, because negative 5 to 2, these 3 regions, is negative 77 over 6, a negative area. Well, I shouldn't get a negative area from these. What they're really doing is they're taking this area, which is negative, adding it with this area, and adding it with this negative area, and its total is negative 77 over 6. And you're going to be able to see that here in a second once we do the problem the way it should be done. So let's now break this up. What they really want you to do is they want you to integrate this thing from negative 5 to negative 3 to find this area. Take the absolute value of that. Integrate it again from negative 3 to 0 for this spot, and then integrate it again from 0 to 2 for this spot. So we're going to have 3 integrals, and they're going to look like this. We're going to take the absolute value of the integral, it's a bad integral sign, from negative 5 to negative 3 of the function, negative x squared minus 3x, dx, I should write. And we're going to add that with the absolute value of the integral from negative 3 to 0, negative x squared minus 3x dx. And we're going to add that with the absolute value of the integral 0 to 2 of that same function. And you should be able to see why this makes some sense. If I use that, if I put that up there, you can see that I'm trying to find this area in this integral, right? This area. This integral finds this area. This integral finds this area, and we take the absolute value of each of those, and that'll give us a total area. So we can use the calculator to do this. We already have a lot of this already done because we know the integral of this is this function. So let's go ahead and write these then. So it's the absolute value of negative x cubed over 3 minus 3x squared over 2. Evaluate that from negative 3 or negative 5 to negative 3. Plus absolute value of negative 3, absolute value of negative x cubed over 3 minus 3x squared over 2 from negative 3 to 0. And then we're going to add that with absolute value negative x cubed over 3 minus 3x squared over 2, evaluating that from 0 to 2. Okay, so all we've got to do is plug in negative 3 into this thing and subtract out this plugged in there. So let's do that in the calculator. I think that makes a lot more sense to just kind of use our calculator to our advantage. So let's start by saving negative 5, which we already did that before, but we'll save it again. Negative 5, stores x. And let's go up and grab the function, which was right there. And we end up with 25 over 6. So this second part, when you plug in -5, is we're going to have minus 25 over 6. Oop, I need to plug the -3 in for x. When I plug that in, I get -9 over 2. So I get -9 over 2 minus 25 over x. I'm going to take the absolute value of that. And now I'm going to do the next part. So I'm going to say plus. Well, we already plugged in -3 into this. And when we plug -3 into this, we get -9 over 2. So I'm going to write I'm going to have minus -9 over 2, right? Because we always do the top minus this. So minus -9 over 2. I got to plug in 0. When I plug in 0 there, I get 0. Okay, so that was easy enough. Didn't even have to use the calculator. And then the last part, plus the absolute value of this. And this part I plug 2 in. I need to plug a 2. So let's say 2, store it as x. Let's go up and grab this. That gives you -26 over 3. And I'm subtracting out, when I plug in 0, that gives you 0. Okay. Now let's actually do the subtractions here. So in the calculator, -9, -9 over 2. So I'm just going to go up and drag that down. Minus, let's get a fraction, 25 over 6. So -26 over 3. So I have the absolute value of -26 over 3. And then plus the absolute value. When I do this here, that's just going to be 9/2. So plus absolute value of 9/2. And then when I do this one over here, I have plus the absolute value of -26 over 3. So now if I take the absolute value of these, that just makes those positive. So I'm going to take, in my calculator, I'm going to take the 26 over 3. And I'm going to add it with 9 over 2. Better put a fraction in there. 9 over 2. And I'm going to add it with, well, another 26 over 3. So let's make another fraction. 26 over 3. I get 35 over 2. So my total area for this is 35 over 2. Now, let's take I need to check this real quick, because there's one thing that I wanted to show you here, and that is if I were to take these three numbers, okay? So this is the total area doing the absolute value. So if we take this graph that we had here and we add these areas up, the absolute value of them, we get 35 over 2. But the thing I want you to understand is when you integrate from -5 to 2 just directly, without doing it piece by piece like we did there with the absolute values, we integrate it directly, it takes not the absolute value version of this spot, it takes just the negative 26 over 3, adds it with the 9 over 2, and adds it with the negative 26 over 3. So if you see this in the calculator, I'm going to take negative 26 over 3, and I'm going to add it with 9 over 2, and I'm going to add it with negative 26 over 3. So I'm taking, instead of doing the absolute values, I'm taking just the original numbers without the absolute values. And when I add those together, it gives me my negative 77 over 6 number. Remember, we got that area when we did directly. So if we did this, if I scroll this down a little bit, when we integrated this directly from negative 5 to 2, we got negative 77 over 6, and I said, that's a negative area. And what I was telling you at the beginning is, it takes each of these areas and adds them together, and it takes a negative area plus a positive area plus a negative area, and it comes up with negative 77 over 6. But we want to know the total area of the region, and we can't have negative areas actually, so that's why we do the absolute value of each of those, and we do them individually so we can make sure that we absolute value the negative ones, and our total area is actually 35 over 2. I hope this makes sense. It's a good problem.